Okay, so now we need to move on and think about what happens when our object moves closer to the focal point. Remember when we did this experimentally, we found that it became a virtual image. And that's going to look a little different on our diagram, but we're still going to draw the 3 lines, the exact same 3 lines we've been drawing, because it's still a converging lens and we still have the same rules. There's just going to be a little mild twist that allows us to create that virtual image. So our first one is always the same. We're going to go through the top of the object to the lens and then down through the focal point. There we go. There's rule number 1. Excellent. And then we're going to think about rule number 2. Rule number 2, just like before, we're going to go through the secondary focal point, this one, and through the top of the object. Now, before we went through the top of the object and then the secondary focal point, we're just going to switch the order of those so that we hit the lens as well. So it doesn't matter what order, right? It's just a beam of light through the secondary focal point, top of the object, and then it goes nice and straight. Excellent. And then our third, we go through the top of the object and then through the optical center. Excellent. Now, this looks a little bit different, right? And don't be surprised at that. It should look a little different, right? However, you have to remember, when we're doing this, we are looking at the lines that are created, and we're going to try to use them to trace our image. And if we were doing this, then in the experiment, we would have then looked through, we would have stood over here and looked back and said, hey, this is supposed to be a person, by the way, with an eyeball. And they're going to be looking back and looking at this lens and see what the image would look like. And you saw a virtual image because it was inside the lens. So we're going to do the same thing. What we're going to do is we're going to go and trace this, however. So what we're going to do is we're going to trace back our 3 lines and see where they meet. So, because that's what your brain's doing, right? Your brain is tracing those 3 lines back and seeing where they meet. That's what we're going to do. So I'm going to trace this reflected back, and then I'm going to, and I'm using a dotted line just so you can tell I'm tracing it back. This is really what your eye is doing, right? Your brain thinks light travels in a straight line and traces things back for you. We're just going to do it physically right now, right? And then we're going to do this third one. And we should find they meet on the other side because they're not parallel, or they're on angles from each other. Now, it didn't work perfectly, but they basically meet right about there. So just like before, that's where I'm going to draw in my image. I'm going to draw in my image right there. So that's where my image is going to go. It's going to go right here. And now you'll see there's a big difference. There's a few things that are super different about this one. So size-wise, it's quite clear. Size-wise, this is definitely larger. And that's true because remember, if this was something like a magnifying glass, it would look bigger. Its attitude, though, it's no longer inverted. It's upright. It's right side up. So it's upright. Same pointing direction as the original. Its location, well, it's definitely, I could call this further. I could also call it behind the lens. And the reason I'd use behind the lens is to refer to the fact we now have a different image, right? It's behind the lens. It would look like it was inside the lens. I'm just going to move this so you can actually read the writing. And then finally, we have the type. Well, remember, type-wise, we're now looking through and tracing it back with our brain, which makes it virtual. It's actually inside the lens. That's where you would see the images to look through it. I also know it's virtual because it's upright. Upright images are always virtual every single time. So that really helps you figure that out as well.